Hello, we are the Continuum team from University of Wrocław. In this video, we would like to show you some details about our rover. One of our main goals is popularization of knowledge about science, Mars and robotics. But we also want to overcome challenges and learn something new while doing so. This is our passion, and we want to move space community and industry forward. The machine is supported on rocker bogie suspension with 4 electric bike engines and wheels, providing enough power even to pull a car. Our rover is equipped with sophisticated robotic arm that has 5 degrees of freedom and allows us to reach 1.5 meters. In order to communicate between the base and the rover, we use network working on 2.4 GHz and 5 GHz frequencies. Safety is our #1 priority. We have implemented numerous safety systems. We have indication lights that inform about connection and autonomy status. The rover has 2 kill switches. Pressing first one will result in power cutoff on all systems. The second one will disable power in manipulator. We have implemented obstacle detection system that won't allow operator to crash rover into any hurdle. The rover will stop moving when it loses connection with base, or controller is disconnected from base computer. This behavior can be overwritten by operator for autonomous mode if intended. The rover is typically controlled by 2 operators. One is responsible for driving the rover and the other for steering the manipulator. Both are controlled by typical gamepads. Base interface allows us to see rover's surroundings via cameras. We can visualize manipulator position thanks to engines and coders. Operators can change drivetrain and manipulator parameters on the fly in basic interface. We can also visualize other data like depth maps, terrain maps and point clouds. Powerful engines capable of pulling a car can go upwards on very steep ground without any problem. It is equipped with 4 powerful BLDC engines and 4 industrial-grade motor controllers. To comply with competition rules, we had to implement software cap on speed. Thanks to the use of belt gears, our manipulator is pretty light. Our manipulator can operate without a problem on typical switches. We have installed multiple encoders which give us precise position feedback about manipulator position. We can visualize its position in real time. It also allows us to check if movement would lead to collision with rover and can prevent this. We have also implemented the inverse kinematics so we can move the effector to any accessible point. We can easily control the effector thanks to visualization where we can view desired position and change it by gamepad or mouse. Inverse kinematics allows us to use predefined positions like driving position or cash drop position. Last year, we worked hard on autonomous approach to tasks and we are still improving our computer vision. Our main camera is ZED, but we have additional cameras to improve spatial awareness and for task-specific actions. We are using stereoscopic image, depth maps and point clouds from ZED camera for obstacle detection, terrain mapping and visual odometry. All computations related to that data are performed on NVIDIA Jetson TX2.